All right, so this is 5C. This is a really good question. This is going to bring back what we were talking about of the derivative being 1 or dH/dt. So this is a great one. So it says the funnel contains liquid that's draining from the bottom. At the instant when the height is 3 inches, they labeled it for you as well. That's H. The radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. So, in terms of the label, that's not the radius, it's how the radius is changing. Um, so you would call it either R prime because it's how the radius is changing, or we were trying to use this notation dr dt, which means the same thing as R prime, but it identifies the independent variable as time. How did I know it was dr dt? The unit is a great hint because it says inch per second. So that is what tells you that it's changing with respect to time. And the fact that they say the radius is decreasing and at a rate of an inch per second, all three of those things, decreasing is a word of change, rate is a word of change, and inch per second is a unit of change. So all of that is indicating that label would be drdt. It's not the radius, it's drdt. Okay. At that instant, what is the rate of change of the height? So what are they looking for? They're not looking for the height. They're looking for the rate of change of the height. So either h prime, or if you can use this, it's better because it's just providing a little bit more detail. H prime and dH/dt both mean the derivative, but dH/dt gives you that detail of changing with respect to time. And they even say with respect to time. So that's another indication that it's dt on the bottom. So what you would do is take this derivative because you've got dr dt, dH dt, you've got all these derivatives, so that should tell you derivative. And I saw somebody at NIMSY do this, and I really like this notation. You're differentiating with respect to time for all the reasons that we talked about above, right? Because things in this problem are changing with respect to time, so we're differentiating with respect to time. And then what we were talking about before is that these variables don't match. So the derivative of r is not 1, it's going to be r prime, but I prefer to write dr dt. 1/20 is a constant that can move down. The derivative of 3 is 0, and then you go to h squared. So again, this is another example where those variables don't match. So it's not going to be that the derivative is 2h, it's going to be that you need the chain rule here. So let me rewrite. And if you were differentiating with respect to h, the derivative of h squared is 2h. And those are right, h is the independent variable, so you would just get 2h. The fact that we are using time as our independent variable, h squared, you're going to use the chain rule. You're going to move down the 2, leave the inside, 2 becomes a 1, and then you need the derivative of the inside. Again, it's not 1, it's h prime, or dH dt. That's complicated, and they give you 2 points for that because they know it's complicated. So I have my 1/20 that I brought down, and then again, 2 is moving down, the inside is staying, 2 becomes a 1, the derivative of the inside, the derivative of h is dH dt. So that is the derivative using the chain rule for that h squared. And as you can see, that is 2 points for getting that derivative with the chain rule. Then at that point, you're just plugging in, and we already labeled everything. So we know that our height was 3 inches. We know that the radius was changing by decreasing by 1/5 inch per second. So that's your dr dt. And then dH dt is what they're asking you for. So dr dt is how the radius is changing. It's decreasing, so it's negative 1/5 inch per second. I don't know if you want to use the units in here or not. I'm going to leave that up to you. 1/20. 2, the height is 3 inches, and then dH dt is what you are solving for. So once you plug in, then you're just solving this equation. So I'm going to multiply by 20 on both sides. And I get, what is that? -4, right? -20 divided by 5, -4 inch per second. and then 2 times 3 inches dH/dt. So we have -4 inch per second. If you hate the units, just do this without the units. This is 6 inches dH/dt. And then your very last step to solve this is to divide by 6 inches. Okay, I messed something up with my units. I'll figure that out in a second. So that simplifies to -2/3. There's the seconds here. Okay, I have the right answer. I just want to think really fast how I got these units wrong. Sorry, 1/20 radius inch per second. 2, the height is 3 inches. I don't know. I'm gonna think about it and I'll let you know what I did wrong there. When I did this problem, I didn't even use the units. I just had -2/3. Well, I can tell you how to fix this really fast. The height, remember these, this is the height, this is the time. So the unit of time is seconds, and then you need the unit of height, and that is inches. You can see that height is in inches. However, they don't even ask you for the units, so you don't need that, but I am gonna like obsessively try to figure that out. Okay, stop right now though. So then back to the rubric, -2/3 inch per second is the answer, and that's the third point. I'm gonna leave it there for right now, and then I will get back to you when I figure out what that mistake was.